Today I'll be presenting the gas laws, done and presented to you by Sumaya Ghaffar. First of all, what are the gas laws? The gas laws have been around to assist scientists in finding volumes, amount, pressure, and temperature when coming to matters of gas. The gas laws consist of three primary laws: Charles' law, Boyle's law, and Gay-Lussac's law, all of which will later combine to the general gas equation and the ideal gas law. The three fundamental gas laws discover the relationship of pressure, temperature, volume, and amount of gas. And by the end of this presentation, you might know the answers of these three life-related questions. Why does pumping the tire become more difficult as the tire becomes more inflated? Why does the balloon lift upward into the air after the flame heats the air inside it? Or why does the soda eventually go flat when it's left exposed to the atmosphere? Okay, so let's start by the three distinct states of matter: solid, liquid, and gas. So the molecules in solid are closely packed together and contain the least amount of kinetic energy, while in liquid, it's the fluid that conforms to the shape of its container but retains a constant volume. Gas is a substance or matter in a state in which it will expand freely to fill the whole of a container, having no fixed shape and no fixed volume. The first law we're going to discuss is the Boyle's law. It's a relation concerning the compression and expansion of a gas at constant temperature. It states that the pressure of a given quantity of gas varies inversely with its volume at constant temperature. In equation form, the pressure and volume are equal to K, which is a constant. In another way, the initial pressure and the initial volume are equal to K, which is a constant, equals to the final pressure and final volume. As seen in the graph, as volume increases, pressure decreases. Here's an example. A 17.50 milliliter sample of gas is at 4.500 atmospheres. What will be the volume if the pressure becomes 1.500 atmospheres with a fixed amount of gas and temperature? Okay, so the final volume is equal to the initial pressure, which is 4.500 times the initial volume, which is 17.50, over the final pressure, which is 1.500. The final answer will be 52.50 milliliters. Next, we have the Charles law. In 1787, the French physicist Jacques Charles discovered the correlation between temperature and volume, assuming pressure and the amount of gas remain constant. The volume is directly proportional to the temperature, so the volume is equal to YT, where Y is a constant depending on the amount of gas and pressure. Another form of the equation that might help solve problems is the initial volume over the initial temperature equals to Y, which is a constant, which is equal to the final volume and final temperature. This is a linear graph. It shows that as temperature increases, volume increases, which is directly proportional. An example: a sample of carbon dioxide in a pump has a volume of 20.5 milliliters and it is at 40 degrees Celsius when the amount of gas and pressure remain constant. Find the new volume of carbon dioxide in the pump if the temperature is increased to 65 degrees Celsius. So the final volume is equal to the initial volume times the initial temperature, and don't forget to convert it from degrees Celsius to Kelvin as stated in the rule, over the initial temperature, also converted to Kelvin. The final answer will be 22.1 milliliters. And the last law is the Avogadro's law. In 1811, Amadeo Avogadro fixed Gay-Lussac's issue in finding the correlation between the amount of gas and volume, assuming that temperature and pressure remain constant. So the volume is directly proportional to the amount of gas, so the volume is equal to Zn, where Z is a constant. Another form of the equation is the initial pressure over the initial amount of gas equals to constant, which is equal to the final pressure and final amount of gas. An example is 1 mole of helium gas fills up an empty balloon to a volume of 1.5 liters. What would be the volume of the balloon if an additional 2.5 moles of helium gas is added? Assume that the temperature and the pressure are kept constant. So the final volume is equal. The final volume is equal to the initial volume times the initial amount of gas times the final amount of gas over the initial amount of gas. The final answer will be 5.25 liters. Okay, so ideal gas law. The ideal gas law is the combination of the 3 simple gas laws. So we gathered Boyle's law, Charles' law, and Avogadro's law, and we made one big equation, which is the ideal gas law. It states that PV equals to nRT. P is pressure, V is volume, N is the amount of gas, R is the gas constant, and T the absolute temperature. This equation, you can use it in any of the examples we solved together, and thank you for listening.